All right, 2b. So we are looking for some time in the time interval 0 to 1 where the line tangent to this curve has slope 2. And we know that the curve is this sort of x of t, y of t. And we want to figure out where the slope is too. So we know that the sort of Cartesian xy slope of this function is going to be the derivative of y with respect to t over the derivative of x with respect to t. But when we're looking at this as a location, dy dt is sort of the velocity in the y direction, and that's right here. And dx dt is the velocity in the x direction, and that's already right here. So I know that this is going to be equal to e to 0.5 t all over the cosine of t squared. And I want this to equal 2. Now, I can't think of any analytical way to solve this, so go ahead and go to the calculator, graph this, and see where they intersect. So let me do that. I want to graph e to the 0.5x all over the cosine of x squared. And I will graph 2. I want this to be somewhere between 0 and 1, so I'll go to my window straight away and change x min to 0, x max to 1. I'll leave these for now. If it's hard to see, I'll change them to numbers that are closer around 2. So let's see what happens right now. So there's the function. And here's 2. Now, you can see where it is. Let me show you what I was talking about. If I wanted to intersect something at 2, I could have sort of scrunched these closer to 2. So let's say go from 0 to 4. 2 is right in the middle of there. And now, since the y min and max are closer together, it'll be more drastically easier to see. Both will work. You don't need to do that. But if you're having trouble seeing where something works out, that can help. Go to intersect. Go over to my curve. If it's going slowly, you can go to the simpler function. It moves faster. It's worth sort of knowing if you're having trouble getting there. There's a complicated function in there. My first curve is, 2. Second curve is that. My guess is right there. And I end up getting a t value of approximately 0.840.